Hello everybody, we are dealing with problem 2.31 of I.E Irodov series, and the problem is stating, as a result of the isobaric heating by delta T equals 72 Kelvin, 1 mole of a certain ideal gas obtains an amount of heat 1.60 kilojoule. Find the work performed by the gas, the increment of its internal energy and the value of gamma, which is equal to Cp by Cv. So if we begin with this problem, so the problem begins with the fact that we have 1 mole of a gas, so N equals 1 mole. Now the problem which we are having is that the nature of the gas is not revealed. That is, if the gas is monoatomic, diatomic or triatomic, or a mixture of two gases, that is not revealed. The another aspect which is given in the problem is the change in temperature, and the change in temperature is 72 Kelvin. And the process is mentioned over here as isobaric in nature. So we have a isobaric process. So for isobaric process, the first information that is given to us is the amount of heat energy Q, which is equal to 1.60 kilojoule, which is imparted to the system. So over here we can say that since it is isobaric process, so Q is equal to N Cp dt. And now since we have isobaric process, we have two important aspects, that is Cp minus Cv equals R and Cp by Cv equals gamma. So using these two expressions, we can write Cp as Cv plus R, or Cp can be written as gamma by gamma minus 1 times R. So we will be using this expression for Cp, and over here we will try to obtain the value of gamma. So Q is equal to 1.60 kilojoule, that is 1600 joule. Number of mole is 1. Cp can be written as gamma by gamma minus 1 times R. R is 8.314, and the change in temperature is 72 Kelvin, so times 72. So this becomes the first equation which we have, and we solve for gamma. So on solving for gamma, we obtain gamma equals 1.6. So this is the first thing which we have calculated in the problem. Now for the second part, we are calculating the internal energy change. So internal energy change is equal to NCV dt, and over here we write it as number of mole as 1, Cv we are writing as R by gamma minus 1. So I am mentioning over here Cp as this, and this one is R by gamma minus 1. So we obtained these two equations from this equation A and equation B respectively. And then delta T, or the change in temperature, is 72 Kelvin. So if we substitute the values, that is gamma equals 1.6 and R equals 8.314, we get the internal energy change as 1000 joule, or we can write it roughly as 1 kilojoule. So this is the second part of the problem which we have. And now if we apply first law of thermodynamics, that is dq equals du plus dw, then from here we can solve for work done. So work done can be written as delta q minus delta u, and over here we can say this is equal to 1.6 minus 1 kilojoule, that is equal to 0.6 kilojoule. So these are the aspects which was discussed in the problem. Problem number was 2.31 of Irodov series.